Okay, so looks like I am live. All right. Okay, so first thing first, yeah, guys. We just did NumPy tutorials, but first thing first, that whatever I'll be teaching you, whatever we will be discussing over here, will be uploaded to the GitHub repo, which is 14-day bootcamp Cookie Sensei. So yeah, and am I missing something else? Let me think about it. GitHub repo over here. So if you want the notebooks for Python, all of them are right here. If you want the notebooks for NumPy, that's in EDA section of the GitHub repo. And right now, what we're gonna do is we're gonna talk about pandas. We won't get very extensive details, but just outline. All right, let's get started. So just like we import NumPy, we have to import pandas as well. Pandas is useful for data manipulation and basically data frame creation and all the stuff that we will see right about now. Let's run this cell. Pandas 2.1.4 version. Let's check out what's the latest pandas version. Latest pandas version. Yep, I knew pandas 3 was out because I was having a version conflict with TensorFlow and NumPy version. So I remember that Pandas 3 is out, but uh, I believe Pandas 1.6 is the one there in my TensorFlow environment. This is the DS environment. Let's go check it out. TF environment again not visible. I'll have to reload this. I don't really know why it keeps happening again and again. Detecting kernels. TS, torch, TF. Yep, I needed TF. And right about now, I want to search for peplist to take a look at what's the pandas version. Okay, this is truncated. How do you check a pandas version? Check pandas version. See, I don't remember the code. Code is simple. You just Google search the code. It's the logic that matters. So, okay, I'm gonna bring the pandas version 2.1.4. Okay, it's not 1.6. I thought it would be 1.6, but great. Then I believe 1.6 worked with the Pandas 1.6 version works with TensorFlow 2.10 because 2 years ago I used Windows. I used TensorFlow on Windows. So back then I remember. But anyway, let's get started. So just like in NumPy, we have 1D, 2D, 3D arrays. We have in Pandas, what do you call 1D arrays as series, 2D arrays as data frame. So let's create one. So I'm creating, let's say, ARR equals, I should really be taking this cell down, np.array. And what's the array? 1, 2, 3, 4. Yep, sounds about right. NP is not defined. I didn't run the cell in the TF environment, right? So np.array, I have the array right now. So if I print the array out, this is how it looks. I hope it's visible at your end. So right now there's a one list live bracket. I hope I'm live. Mm, let's check. Yeah, I'm live. So, right. Yeah. So one list like bracket means one dimensional array. Now take a look. If I were to say arr dot reshape, it into a three-dimensional array. How would you do that? Mm, let's say I'm writing 1 comma 1. That would be a 2D array, right? 4 into 1 comma 1. 1 comma minus 1 it should be. That's a 2D array, right? One row and four columns. I could have said something like this. One row and four columns. Okay. Then what else? I could say something like one row, one column, and four inner elements, or maybe minus one inner elements. As you can see, there are three list-like brackets. So it's a 3D element right now. When we will be dealing with images, na, then I will talk more about what 3D elements are. And as of now, if you want to like take a look at what 3D elements are, what images are basically. So we can discuss that as well. Yep, this is a 2D array. Take a look. Two list like bracket and two list like bracket again 2D array. So when there are three color channels of red, green, blue, RGB, then it becomes a 3D array. Okay, so this is an image and take a look. These things are like red, green, blue values, and it's a 3D array. One list like bracket, two list like bracket, three list like bracket. So images are nothing but pixel brightness values of RGB channels, red, green, blue. So anyway, coming back to NumPy tutorial. No, no, NumPy. We are doing pandas, right? I'm so sorry for the hiccup. Okay. So just like we have in NumPy 1D arrays, in pandas we have series. So series looks something like this. But if I were to auto print the series, yeah, 10, 20, 30, 40, the output, I believe in pandas version 2, it looks a little bit different than pandas version 1. I remember in pandas the version 1, it was grayish. The outer visual of it was a little bit different, but I could be wrong. Anyway, that's the 1D data frame. I mean, 1D data, which is called series. So the way you do it is, I'm sorry, the way you do it is import pandas as PD. There could be any kind of data, and you load the data into this pd.series constructor. I believe I've never told you what it is, but okay, let's use it as a function then. If you use the function pd.series and put inside data, then you get the series out of it. And you would say, okay, this is so obvious, but okay, what are the 0, 1, 2, 3? This is the index. So that's the difference between your, I would say, NumPy array and C array looks like this 10, 20, 30, 40. Meanwhile, Panda series looks like this 0, 1, 2, 3, 4. It will make more sense when we go to data frames. Over here, I can explain. Can I? So let's say I'm creating a sample data frame, and that data frame is something like two list like brackets 1 comma 2, then second list like bracket 3 comma 4. Take a look. Yep, this is the data frame. So it's like very much Excel like, right? The data that you see in Excel, rows and columns. This is the row, this is the columns, this is the row indexes 0, 1. Anyway, so indexing in this thing could be done by Google search, basically. Data equals 10, 20, 30. Then you could pass the index, you could pass the column names. I believe if you want to pass the column names, that happens in data frames, not series. But let's check. Can series be named? Yes, I think series can be named. So name a pandas series. How to name a panda series, basically. Pandas.series.name. Name attribute is there. So let's name it, and I'm gonna name it, let's say s dot name, mm, equals Apple. Because why not? So right now, what I'll be doing is I'll be printing out S. So see, take a look. The series is the same, the data is the same, but the data has a name now, Apple. So it will make more sense when I create a data frame out of it. And let's say if I create a data frame out of it, I could like put some column names in it. So over here, if I go back to the data frame, I could use either column names or columns. I believe I don't remember the syntax. The first column is, let's say, mango, and the second column is, let's say, berry, any kind of berry. White array. Okay. So see, column names I've just renamed the columns. It just yeah, easy thing. Let's go ahead and create some data sets. So I just briefly talked about pd.dataframe constructor, and one way to create the data frames is by passing a 2D data to it, like data frame pandas. I'm searching for the documentation right now. Oh, W3 schools in GFG also have their tutorials for it. So default by default, pandas takes a dictionary. So a dictionary of key and values. So if you put something like col1 and pass the values as a 1D series, or basically 1D numpy array or a Python 1D list. So this is how it will look like. pd.data frame data equals d. Right here, to me it's very obvious. I don't know how obvious it is to you, but or maybe I could be going very fast. The second way is to pass the lists just like this, the way I have done. pd.dataframe, give it the np.array. We are giving it a 2D array right now of first row, second row, third row. Columns are A, B, C. So right here, there is another way. Okay, they are just assigning data types. We don't really come across these kind of situations often where we would need to assign the data types. So we will stay away from this for now at least. All right. Just like that, in the same way, I'm creating a dictionary first, dictionary of key and value as a 1D list, Python list. It could be an array as well. It could be pd.series as well. So let's see what else. Whenever we load a data set, it's a best practice to check for some missing values, headers, tails, like for say df.head. We will take a look at more like what df.head does actually. df.head header gives me like first n rows. So give me first two rows. It gave me first two rows. df.tail give me last two rows. Give me last two rows. So df.info, let's try. Info gives me the data type, the non-null values, three non-null, three non-null, three non-null. Okay, there's a better way of checking. If you want to check missing values, there is a better way. And I believe that used to be dot is null dot sum. So when you write dot is null, now it will give you a boolean indexing just like in the numpy array of where the value is null basically. So right now, no, there is no missing value. So every element over here is false, saying that no missing value is over here. And then we can just sum it across the columns. I believe the default axis is columns, but we can switch it to a row axis as well. This is the row axis, and this is the column axis. And so we will talk more about this thing later on when we are doing actually the projects. Then what's this? This should be df.describe. Yep, df.describe. It gives you a statistical summary of like a count, the central value, mean, the standard deviation, the minimum, the maximum, and 50th percentile value, 25th percentile. Basically, if you want to check the percentile manually, you can do that as well. I remember the code. It's like np.percentile. Oh no, actually I forgot the code. So how to check percentiles manually? NumPy percentile function, NumPy percentile. So if you want to check the percentile, you give it a, like what I'm doing right now is not exactly teaching the code. What I'm doing, what my intention here is to tell you that people keep forgetting the code, and it's easy to forget the code, and it's okay to forget the code. What you should be good at is reading the documentation. So NumPy, not percentile. First argument is A. A is something like array of real numbers. Okay. Then what else do you want? I want a percentile value. Then I want Q, percentage or sequence of percentages for the percentiles to compute. So A and Q I want. A could be something like my data frame that I just created, which is DF. Okay. DF I have just created, and I want the 0th percentile. Let's choose a 1D array. That will work only. So 1D array could be something like 5, 6, 7, 2, 90. So I can see the minimum value is 2, the maximum is 90. So the minimum value, the 0th percentile value is 2. Highest percentile value, which is 100, that would be 90. And it's giving me float because I could have asked for, let's say, the 99th percentile value, which is, I mean, if you want to compute the 99th percentile value, it would be a decimal point, which right here is like this. I don't have my tablet screen right now, otherwise, I would have perhaps given you more detail about what statistical summary is. But anyway, let's proceed. This is about pandas, not statistical summary. So we created the data frame earlier, right here. Alice, Bob, Charlie, 25, 30, 35, and New York, London, Paris. So if you want to pull out a column from a data frame, there are two ways of doing it. But first, let me show you the documentation. Pandas check column, I believe that's the query. Check column or pull column out. Pull column out. Select a single column. Yeah, that's a better thing. So df inside the indexing brackets, you put the column name. Let's try it out. Df inside the list like brackets, you put the column name. Then it will give you the series because it's a data frame. So when you ask for a column, the column gets returned as a series. And the second line is a 2D kind of indexing where you can index not just one column but two columns at once or multiple columns at once for a fact. Okay. There are various ways of indexing data frame through column names, through iloc. I personally use iloc, and we will be using iloc most of the time because in machine learning, what would happen is, let's say you have a data frame. In this, I want to use name and age as, let's say, a different data frame, and the last column as a different data frame. So I can integer locate, and I can say take all the rows. Semicolon means semicolon as the first argument means all the rows, and semicolon, or it is column, as the second argument means all the columns. So right now I'm selecting the entire data. So let's say I want to keep the data for row 1 and row 2. Then I want, let's say, uh, column 3. Let's go ahead. Oh, actually 3 is out of index. 0, 1, 2 should be the case. So yeah, Python's indexing start from 0. I forgot. So row 1, row 2, and of the second column. I could, keep all the three columns as well. 1, 2, 3. Then again, the same error. 0, 1, 2, it should be. Been quite a long time since I'm using Python. Okay. So integer locate is there. There is df.loc, which locates the items using the names of rows or columns. So let's see what else are there. Row selection with loc. You can say dot loc 0. I believe 0 will give you the first row. 0 to 1 will give you the first. What else? Let's run it out now. 0 is giving me name and Alice. Let's print out df again. Let's check it out. What's df.loc 0 is giving us? I believe it should be giving us the first row. Alice 25 ny. Alice 25 ny. Yeah, it's giving us the first row. And then I'm printing out df.loc 0 to 1. Right now I'm asking for 0 to 1. So it's including 0 and 1 as well. There's a nice catch. I didn't know that the second parameter is also inclusive in pandas. I just figured it out. Okay. 0 to 2 over here gives me 0, 1, 2, 0, 1. Why not 2 then? Acha, this is the ilock attribute. Okay. So masking inside the data frames happens with something like this. You print out data frame, and then let's say you want to filter, you want to create a mask where the age is greater than 27. So I will say data frame, select the first column, the age column, and wherever the age is greater than, let's say, 27, it will give me a Boolean index. And I can use this Boolean index inside the data frame itself. Data frame use the Boolean index of this thing. So what would happen is row wise it will be calculated. First row is false, so first row will not be returned. Second and third rows will be returned Bob, Charlie. It will make much more sense when you are the one actually coding it. I'm only talking about it right now. So then again, filter data frames you can use. If you want to add columns, just Google search it out. But then again, adding a column, you are providing 3 rows of a new column and assigning using the equal operator as df salary. So take a look, name, age, city, and salary. Yep. Dropping out columns you can delete. There are various ways of deleting columns. This is just one of the ways of deleting columns. Handling missing values. Let's say if we have a data frame with missing values, like right here, you could fill the missing values with mean of the entire column, with the median of the entire column, the minimum, maximum, or any random value for a fact as well. So right now what we are doing is we are first printing out df missing. So this is the df missing with 2 missing values is na. So it gives me a Boolean data frame where it tells me, okay, over here I have a missing value, over here I have a missing value. So fill the NAs with 0. Fill the NAs with 0. I don't want to do anything with the NA. I want zeros over there. Most of the times we have to fill the NAs with zeros. Why? Because machines understand only zeros and ones. That's very basic explanation, as this is a beginner oriented tutorial. So if you want to sort the values of a data frame according to a column, you can use sort values, or I would rather just Google search. I don't remember these syntaxes. Group by, this is where things get interesting. So we have created a data frame like this, and let's print out. So the data frame goes team A, B, and then the points. So if I want to group by, and let's say I want to check the mean points of the team A, mean value of the team A. That should be 10 plus 20 by 2, which is 15, right? So over here, the syntax goes data frame dot group by. Which column do you want to group it by? It will give you a group by object. Let's say df group dot group by, and group by what kind of thing? Let's say it's only one column over here. So what was the column name? Team. It will give you a group by object, and I can ask basically various things inside it. If I pass the aggregate function, I could there are only one value, so only mean makes sense. Mean over here, let's say I want to say max as well, max over here, team wise maximum, and let's say I want to calculate the minimum, the median, and what else can be done? We can sum, we can use count. And why do I know this? I know this because I've read the documentation a lot of times. That's it, really. And if you want to do the same thing, you can just Google search for pandas group by aggregation or aggregate. So you will find this same function pandas.core.group by.dataframe dot aggregate. Slip of tongue. So the dot aggregate function should be right over here. Yeah, right here it is. The dot aggregate. You could aggregate with just one structure or one function, minimum, maximum, mean, count, sum. You could use a list of two, list of multiple values. You could use a lambda function as well. Have I used lambda function before in this tutorial when we were doing Python? Yes, I believe we have. So let's take a look and use the lambda function, because I don't know, I've never really used lambdas with the group by, but okay. So I'm first of all creating a group by object. Then I'm saying lambda function. What was it? What was the syntax again? Dot aggregate lambda. Yep. Dot aggregate. Inside this, I'm saying lambda x team wise aggregate, and team wise. Let's just say I'm gonna say x uh minus mean minus x dot mean. Will that work? Nope. What I'm trying to do basically is zero centering the data. At least that's what I'm trying to do. I'm not able to do it right now, but that's what I tried. And whenever you get errors like this, just copy and paste it into ChatGPT. What I'm teaching you right now is same, like very simple thing. That is, uh, coding is easy. It's the logic that matters. So over here, it's telling me to import this thing team lambda x minus x dot mean x minus x dot mean. I'm using the same thing, na? X minus x dot mean. Mm-mm-mm. Let's think about it. When I group by, let's use this syntax first. Why this works and mine doesn't? Must produce aggregated value. It's not working, right? Ah, it's not aggregate, it's transform. Okay, I missed that out. Transform, yep, I can tell transform is used a lot. So dot transform zero center the data, meaning that the sum should be zero. Sum of the teams should be zero. Data frame dot group by the team, group by the team, then transfer the data. Transfer no, not transform. Transform the data, zero center. Although we have libraries for zero centering the data, it still is a good, you can say, good practice to know at least how the transform works. We will see as the project comes, like how transform works, and this group by transform, where it could be used, and so on. What else is there? Let's see. Aggregations, we have done aggregations. Merging the data frame, if you have done SQL, it will be easy for you to understand. Like if there is a left data frame and then there is a right data frame, And let's first print it out left and right. So left goes like this, right goes like this. So right now I have IDs, same IDs, 123, IDs 123. The names are Alice, Bob, Charlie, salary is 50, 60, 70K. I want to map them in a way that the left data frame and the right data frame gets horizontally stacked. I believe that's a horizontal stack. Alright, let's try the horizontal stack way as well. np.h stack left, right. Let's see what's the output. But two were given. np.h stack takes one argument. Oh yeah, it takes one argument really as a sequence it takes. Not sequence but as a list or a numpy array for a family. So right here, if you use numpy.hstack, it will just literally take two data frames and just stack them like this. But I want this ID column to not be repeated. I want that these things are merged using the ID, just like you do in SQL. So pd.merge left right on ID. So right now, wherever the ID matches, it will merge or stack the columns. Concatenation is, I believe, vstack, pivot tables. Pivot tables, yeah, let's look at pivot tables. So let's create a pivot data first of all. So we are creating this data frame, city, year, sales. Then let's say you want to pivot it. Pivot in a sense mean that like take a look. NY, London, London. Now you're pivoting. Dot pivot table. Value equals sales. I want these values to be sales. These values 90, 130, 100, and 120. London 220 is 90. London 2020 is 90. Right? So I'm just pivoting the data. And I'm using rows as index. I mean, I'm using rows as index, which is city over here, and columns as year. So rows as city, which is the index, columns as the year. That's a pivot table in a nutshell. Time series, it's very confusing. So I will just go to Google and ask for pandas time series because God knows if they have changed their uh, syntax. So import datetime. Okay, we have a pd.to datetime function. Basically, you should read this on your own. But if I were to just give you an overview, it would be time series is literally a time series format of date, time, hours, minutes, times. There could be a different formats of capturing. Like let's say pd.series create a series of period range 1st of January of 2011. Frequency is months and 3 period. So this code gives you 2011 1, and basically there should be a format as well somewhere. Like if you don't specify the format, it will like right here it is automatically taking the year first, then month, and if you specify the date as well, then it will specify the date later on. But there's a format as well. That's what I'm searching for. Yeah, right here it is. The confusing thing. So you have, let's say, you have a pd.datetime. Convert this date time, and the date time is year. Then I believe this is month, and this is the date. Convert this, and the format is percentage y, meaning the the four number of years. Percentage lowercase m means it's a month, lowercase d means it's a day. But take a look at the timestamp. Even hours, minutes, and seconds are being printed. So if you explicitly want them, you can list it out just like this as well. Hours and minutes. And for the seconds, I believe it will be percentage s. or somewhere it should be written. That's about it for the pandas. I believe there are some methods which we will look when the time comes, when we will be doing more projects. Oh yeah, apply functions. Apply functions. We shouldn't miss apply functions. So let's say data is this, and I'm capturing the data and one column out of it, which is points. So let's say I want to transform this uh, series in some way. So I will say data frame, capture one column and apply to it this particular function lambda x, and let's say x plus 1000. So you see 10 got converted into 1000. Take every row and add 1000 to it. Let's say take every row and multiply 1000 to it. You can see right here how the transformation is happening. All right. Rolling window is also, I think, important topic. So let's discuss it. We won't be going too deep into this thing though. So pd.series rolling window. Uh, right here we have created this S series. S dot rolling, take a rolling window of 3 and capture the mean. Meaning that take first 3 elements, capture the mean. Initially, there is a missing value because for the first element, there are no, you need to have 3 elements for mean to be computed according to this syntax. So the 3 element condition gets fulfilled on the third element itself. So only the third value is giving you a particular non-null value. So for the 1 2 part, it will be giving you missing values. For over here, it will do 1 plus 2 plus 3, which is 6 divided by 3, which is 2 right here. And then the rolling window would go 2 plus 3 plus 4, that is 9 divided by 3, that will be 3. And then 3 plus 4 plus 5, that will be 12 divided by 3, that will be 4. I hope you got the gist of it. As for the basic visualizations, you can use the data frame and just put it into ChatGPT, or we will see more inside the section of projects. How to load data, how to save data, everything we will be checking out in the project section. Yep, we are good to go. Thank you for watching, guys.